Hello and welcome to the video. In today's video we're going to look at the Bluetruth documentary. In this documentary, Dr. Pedro Chavez claims that he can receive Bluetooth signals from the vaccinated. He also makes a claim that these Bluetooth signals can be received from the people who have passed away and are effectively in a grave. And we will also see how they don't use the Bluetooth equipment they're using properly as well. This is going to be a very, very long video, so grab yourself a beer, grab yourself a coffee. You're probably going to need it. I'm going to leave timestamps in the description so you can skip to the juicy bits, or you can, as I say, grab a 6-pack of beers, sit back and watch me destroy some anti-vax scammers. Thank you very much for watching the video today, and let's get on with it. Let's do it. The claim. Okay, so we're going to examine this. Already off the bat, I can see appears to be a tablet, an iPhone. Okay, so we're up to 4 devices. So theoretically, if you are pulling the data through the Bluetooth module, and this laptop's BLE capable MCU is active, then that is going to register 1, 2, 3, 4 devices. Now, as we know with LE privacy, if these devices are randomising their Mac addresses, then that Mac address will not be available on the OUI database. We also have a smartwatch, I've just noticed there. So we have potentially, just here in this shot, 5 devices.
Ahorita, tiempo cero, no habemos ningún vacunado y no hay ninguna lectura de Bluetooth. Que pase, César. Lleva para allá.
Okay, I can already see that that's definitely the Android settings. That is checked for Bluetooth on. Another device is shown up here. That looks like a Samsung Galaxy device. So potentially we are up to 6 devices. What's this on his wrist as well? Is this a Bluetooth device as well? We're potentially 7 devices here. Okay, let's crack on.
Este ya está listo esto para leer.
Sí, padre.
Luego agarró. Sí. A ver. Bien. Entonces, código D.
This is where we can draw a line under the first line of bullshit, and it's nothing to do with the MAC address. That's clearly probably a randomised Mac. Is this Bluetooth LE devices? The Bluetooth 1 dongle they are using under sources is not classed as a BTLE device. It has its own source name of Bluetooth. So they have an Bluetooth 1 plugged in, but they're not using it. The French guys who did it in the field in my other debunking video, I actually did a second video on that, which was basically, I did notice that it wasn't showing up as the Bluetooth one. These have done exactly the same. This is not the Bluetooth capture device. Any packets or data you see here has not been found by the Bluetooth one. There seems to be a pattern here with these guys and the French guys in the field. But anyway, let's crack on.
De dedo 9, 36, sí. 54,
Sí.
F de foco D, de dedo,
Sí.
99,
Sí.
52.
Yes, so yeah, this Bluetooth device is activated, and as you can see, it has stopped looking or stopped advertising its normal MAC address. So now what this is doing, because it's not advertising, so when you first want to pair a device, you get however many seconds, it's up to the manufacturer to set, but you will only broadcast your OEI manufacturer MAC address or recognised MAC address for, say, 30 seconds, a minute maybe. Once that time's up, this device stops advertising, and then it backs off, and LE privacy kicks in, and that MAC address becomes randomised. So straight away, this is sending out a randomised MAC address. If I check that back to off and then back on again, out of the box, that will generate a completely new MAC address once the advertising has stopped. But this will generate a completely new randomised MAC address every 15 minutes as well. So what they say is potentially people who are vaccinated, even if that be the case, which I can assure you it's not, it's all bullshit, but even if that be the case, effectively what's happened now is you've skewed the data. You have added these variables to that data, and it's corrupted your data.
654.
Right, so jump forward here. They are checking the OUI database of the Mac. I'm sorry, but that tablet, the other devices you've got, they're all randomising the MAC address. Even your Windows computer on the right hand side is randomising its MAC address, and that's probably what you're reading, and you're putting that into an OUI database, and it's just a random MAC. But they know this. I mean, come on, they had a smartwatch, a tablet, they've got 3 phones, 2 laptops. They know exactly what they're doing. And they're all on. They're clearly all on. Anyway.
654. 362 puntos. 54F. Sí, con los 3 primeros te da. Esta es una página para detectar los fabricantes de los códigos Media Access.
Yeah. This, that, the other guy's phone, this iPhone, the laptop, that laptop, the Bluetooth itself, they're all just generating random MAC addresses. I say that this data is skewed. Even if that guy stood there in the checkered shirt, did have some nanotechnology in his body and was producing a MAC address which is randomised, your data is fucked. The program. So this is our program. Oh, well, should I say our Bluetooth bullshit detector program. So it's a dead simple program. So we statically declare our serial port object as port. We have our GUI here, which prints everything out to a text area. Pretty straightforward. Obviously, title of our program there. Okay, so we create an array of serial ports, port names. We serial port.getCom ports, so we grab the COM ports, we put it into a little for loop, port name, port names, and then we add items to our port name list. All that is controlled down here, so we have our action performed, action event method. So if connection button.getText equals connect, then we basically allow the system to grab our port list. So get our selected item to string, present it to user, then we set our COM port timeouts to 0, so we want it to run forever. Our baud rate, which is our Bluetooth feather, Adafruit Bluetooth feathers baud rate, and our bits is 8 bits. So we have a condition that if the .open port connect button set text is disconnect and write, then we basically say, well, we want the port list not visible to the user, so the user can't halfway through the program change the port list. Then we get onto this next block, and this is our Linux standard in-out class, so we declare that as lin. So inside that we have a method called lingo, which is called here. If we go up to that, what that does is just uses a bit of bash flu, a bit of bash, excuse me, a bit of bash foo. So we create a process builder. We look at the directory of our home directory, which is basically Arthur. So we have our command, which is bluetoothctl, no, they call it Bluetooth, Bluetooth control scan on, and we use a bit of bash foo just to pipe that out to a txt file called capture.txt in our main consolidated capture directory. Below that is Android Go, but we'll come back to that, so that executes at the end of the program. Cool. So then this leads us on to our first thread. I did originally do this as a thread factory, as runnable. The problem I had is just it was choppy and I couldn't quite allocate enough memory for it. I'm going to work on that and get it right, because I'd rather do it in a thread factory. It's my preferred go-to when dealing with multi-threaded programs. But as it goes, I've just done 2 threads which basically all call on the run method. So both inherit the run method, so they run concurrently together. Our first thread is obviously references to a scanner class. Then we call on our port, which we declared, and we get an input stream from our ports. Put it into a little loop, so while our scanner dot has next line, try, and then we declare our string line is equal to scanner dot next line, and then we have our regular expression, and that's just our comma separated value. So all the data from the input stream has a CSV value, so we can split the string with that. Then we just have this little nested for loop here, which sets text to exit string, and then TA, which is our text area, we just append that to it. We create a new line, so after every line that comes in, we generate a new line, and then it basically repaints that to our GUI, or should I say our rolling capture, our live capture environment, which we'll see once I launch the program. Our next thread is basically just a file writer or file output stream. So we declare an instance of a file name named temp.csv. So this is our temporary comma separated value file. We create a new file name, which is obviously temp.csv, create that file, and then we try to grab a file output stream. So we kick off a file output stream, we take a reference to the input stream of ports, just like before. I think that's what the problem was when I did with the thread factory, but I digress from that. We create a byte buffer, we write in, so we have an integer of the byte length, buffer length, it's equal to 0. So what we want to do is we just want to make that greater than 0 and just keep that while loop going, and then we write that out to file with our buffer length. Cool. So our next condition, which relates back to our original port if condition, is port.close port. So once the program is finished, we close the port, then we set our port list again, set enable to true, so now the user can re-interact with the port arrays, the arrays of ports. And also as well, we change our connect button back to connect. So now our program is reset into a kind of, it's just standing by ready to re-grab some more data. So the user clicks connect again, we grab new data. Below that, we create 2 class objects, and the first one is POI file.write, and we declare it as POI. Then we try for that, so we say POI.go. Now what POI is remember our CSV file from here that we captured, well, in our POI write. So what we're going to do is we're going to declare a string of, basically we're making a string declaration there of CSV file. This is the directory, then we make a string declaration of xlsxout, which is that directory. We call on our go method, and also it does, it creates a workbook with Apache POI, it creates a sheet, we map strings and objects to an array. Then for our first line we put, this is just like a, suppose, a statically assigned placeholder of this is just above, so telling the user what the data is. So we grab a MAC address, we grab the raw packet data, and we grab the manufacturer data. We set that string, and we set a integer of row ID to the sheet. We put it into 2 for loops. The first one is just obviously the key ID, and then what we do is just increment our row IDs of the objects. Then again we create an integer of our cell ID, and we basically same again, we're just going to increment that. So as the data comes in, it just increments it. So our string, we declare string current line. Now current line is going to pull all our data from our predetermined CSV file that we've created. We have a hash set, which basically once after we've declared that as an array of string, this is down here in this if condition. So if the current line is equal to br.readline, so effectively what it is it's just looking for data that's replicated effectively. So we create a row in our sheet, and we create a row number, and we just increment that data. Dead easy. So then we write our file output stream, file out, and we set that off. So we grab the XLS file absolute path there and just write that to it. We then workbook.write, so we execute that with the write method, and then we call close for the workbook buffered reader. Right, so below that in our main is our and.android.go. So we are calling on our Android Go method back in our Linux standard in out class. Also do here in our Android Go method is we just create a new process builder, very similar to, well, it's the same really, and we just execute some bash foo. This time what we're going to do, we're going to change our directory to Android SDK platform tools and execute ADB pull. So the Android Debug Bridge now is going to pull the data from the phone that's plugged in via USB, and it's going to look for that data in the SD card directory, and we're looking for our Bluetooth Snoop HCI log. And then we're going to pipe that out into our directory on our machine, save it to that, and that's the last action of the program. Dead easy, dead simple. Right, so time's come to execute the program. It's dead easy, foolproof. Cool. So you can see before, as we talked about, I've only got one serial adapter in there, but multiple serial adapters would show up. So once we hit the connect button, like we talked about in our first 2 conditions of the program, it blanks out, so the user can't interact with that and change it and crash the program. And we can obviously disconnect, and we go into our POI write method at the end, and obviously call on our Linux class as well to do our I/O and our process builder. Cool. So this is just running. You see live capture. It's pulling all that data in. Cool. Okay, so you've got a bit of a capture going on there. So now if we disconnect and write, as you can see, we've grabbed our BT Snoop Log of our Android device using Android Debug Bridge. We've created our capture.txt file from our Linux Bluetooth control scan on command. We have our temp CSV file, and now we have our basically Microsoft Excel file that is. So this is our program, or our C++ program, that we export to our Adafruit Bluetooth. Dead easy, just one loop. This is basically their stock scanner program. I've just added the length equals to bluefruit.scanner there, parse report by type. This is just looking for the gap type manufacturer specific data. So dead easy. The capture. analysis. Right, so we're going to analyse our data that we collected on our little trip into Manchester city centre. So this first document is the Microsoft Excel document we created. And you can see we managed to get 10,742 captures on that. This is just the bottom of the document. Already I'm seeing a lot of Apple there, 4C00. Obviously this is at its Indianness change, so it would be 004C. Yeah. Quite a few. It's amazing just how many Apple devices there is and how many broadcasts. I find that absolutely amazing. All these MAC addresses will be random as well, so every single one of these Macs, if you were out there just with your phone open, you would see every single one of them as a random device. Cool, so going to move on to the HCI capture that we did with the Android phone. Now with Wireshark and the Android phone, this is really good. So I've not wrote the reader program for this yet. Once I write the reader program, it's basically going to take that first, say, 16 bytes of the data, and it's going to turn that, and I'm going to have a helper class with some setters and getters that basically references that as a list object and says if 4C00 present Apple, so an extra on the program itself will come up like a chart, and at the end of it, basically, then we'll take how many Apple devices, how many Samsung devices by the manufacturing data, and we'll give a nice bar chart of how many devices. And it'd be good to actually see how ubiquitous and the kind of proliferation of Apple over Samsung in live environments, albeit which phones possibly advertise the manufacturer 16-bit address and how many don't. Because obviously, like the Zettel card readers that are in the shops and the point of sale systems, they're not really going to give you that much information. But yeah, the peripheral devices that are connected to them, the iPads and obviously the Microsoft Windows systems, they will effectively give that information. I think with, say, Bluetooth, you might be able to correlate that data to the point of sale system that's actually running the software, like the Android device, iPad, Windows tablet, whatever. Alright, cool. So, okay. Now, we have... This is our Android HCI capture that we did. So, also we've done is take the BT Snoop HCI log off the, if you watch the start of the video, well, after the introduction and after I'll let the anti-vaxxers have their say and show obviously what they're trying to say, or should I say the bullshit they're trying to say. You would have seen that the programmer wrote automatically grabs this off the Android device that was in my bag when I was out. Cool, and this is basically it. So you can see here is just one capture of one device. So we have a MAC address. We can see that the peer address type is random, so this will come up as just a MAC address on your mobile phone. But when we dig deeper in, just like previously in my programs capture, we have a 16-bit service class of the UUID, and that's basically saying it's a heart rate monitor. Then we have the device name, which is Whoop. Why? I don't know. Cool. So what we can do now is just go through random devices. So there we go, as we're talking about 004C, Apple Incorporated, but as again, type random device address. This is what the people are seeing on the devices. So these devices, because of randomised, are not on the OUI database. If there was, Wireshark's backend has an OUI list of manufacturers, but it's not presenting that there as Apple, but it also has a manufacturer specific 16-bit address type, and it's saying, look, it's Apple. Okay. Yep, Apple Inc. Apple Inc. I say it's amazing how many Apple devices there is out there. Apple. 39, that looks oh, it's the same. Okay. Yeah, Apple. 46, interesting. Yeah, Microsoft. Oh, there you go. Something different. Yep. Microsoft. Probably Windows 10. Yeah. Just same again. Apple Inc. 23. Yep, Apple Incorporated. Apple. There's the pattern here, isn't there? Of randomised, another Microsoft machine. Obviously, these would be machines in shops as I walk past and stuff. Cool. 43. Oh, cool. Yeah. Here's another, which in my previous videos I've talked about, is the exposure notification. You can see randomised address, and then our 16-bit UUID is an exposure notification, but on your device, as the anti-vaxxers are telling you to do, and they're saying, look, go try it yourself, do it yourself, look into my eyes, not around the eyes.
Look into my eyes, look into my eyes, the eyes, look around the eyes, don't look around the eyes, look into my eyes.
As they're giving you the bullshit cascade, this is what you'll see. You're not going to see that in a normal Android application or a normal Apple application. You will not see that. You'll only see that MAC address as a random MAC address because it has set the peer type to random. And again, scrolling through, you know, it's just device after device. Apple, I'm amazed the proliferation of Apple. Obviously the Microsoft are probably shops, computer systems and stuff. Oh, we've got a Ericsson there. Ericsson licensing. So that's a licensed UUID. Oh, Tencent Holdings Limited. Okay. Ah, cool. Ah, alright. So I don't know what that would be. No, the manufacturer specific is Ericsson, but it's licensed to Tencent. Yeah, interesting. It's amazing what you learn with these. But yeah, again, it's Ericsson, Tencent, another Microsoft machine, Apple. Yes, it's amazing the proliferation of Apple devices out there in the wild. Yeah, another Microsoft machine. Let's go a bit further up the capture. Yeah, another exposure notification. Qualcomm Technologies. That's clearly coming through as a headset. So that Qualcomm chip is inside somebody's headphones. And again, you know, you're not gonna, it's a random device address, you're not going to see that data, that packet data, in your Bluetooth scanner app. Cool. Yeah, another exposure notification. Apple ID. Qualcomm Technologies, that's probably the same headset actually. Might have actually been probably walking behind somebody with that headset. Another Microsoft machine. Another Apple device. I mean, we can go on and on and on and on here. But yeah. Oh, that's a good one. What's that? What? Immediate alert. Yowu Selkirk-Fox. Yowu what? That's very interesting. Yeah. Yes, this is a public device address, so this would be visible on your phone. So Rayston TE. Rayston TE. I'm assuming that probably means tech or something. Media alerts. That's a strange one. Rayston. Hang on a minute. Yeah, this is a strange one, so it's worth a Google. Ah, cool. Audio module. Nice. Cool. Right, well that's sorted that out then. Nice, right, yeah, so it just shows you how it can throw little spanners up like this. So yeah, right, so it's obviously that's a public device, so if we go to that, that's a random device as we're talking about, and that one is a public device, which is 0x00, and a random device is 0x01. Cool. Yes, another weird one. What have we got here? Well, it's advertising as Google. Amazon.com Services Incorporated. Oh, right, okay, yeah. So this will be, I think, a Kindle, because Amazon uses the Android subsystem and all its Delvic VM in its Kindles. So I think that'll be that. I don't know. Go Google all that data for yourself if you want. Device name LEWH yada yada yada. Okay. As again, you come into all this, but they're clearly identifiable. Other than if you use an Android phone, you just see that Mac and go, "Oh, it's the vaccinated. It's not that." Well, it clearly bloody is, isn't it? So okay. More Apple. Sony. Apple. Type service data. Google Incorporated. Yeah. Yep. Qualcomm. Oh, that's probably that same headset from before, is it? Or maybe that Qualcomm headset is quite ubiquitous and it's in quite a lot of devices. Yeah, Google again. It's probably the same device, so I might have to just get a bit further away from that timestamp. Yeah, another Microsoft Windows machine. More Apple. More Apple. More Apple. Jesus Christ. Apple. Oh, right, Apple. Google. Google. Apple. Google. Apple. God. Random 34. The Apple. Microsoft Windows. Apple, Microsoft, Apple, Google, and Apple exposure notification, i.e. the COVID applications that you download, the proximity ones, which is loads of them knocking a root. That's probably the same device, so because obviously we're pulling a lot of data in, so if we're in the same place, it's thereabouts. There's only so far you can walk in a shopping centre in human traffic. Or should I say there's only a set amount of speed you can, so... Yeah, Microsoft. Just randomly going through. Interesting. Oh, Microsoft, okay. Yeah. Didn't quite see that, and it's like, oh, something new. Maybe the anti-vaxxers have got an idea of, oh no, I know, here we go. Yeah, so this is a malformed packet, as we talked about before. So see, there's only 15 byte's been received. So let's clock that 5D OE. Okay. Oh, there it is, yeah, 5D. So we can see how the malformed data there has basically stopped us from finding out, oh, what device is that? And, you know, if you, the anti-vaxxers could say, like, oh, well, look, there it is. Look, there's nothing coming out of that one, mate. You've dropped yourself right in it. Shot yourself in the foot there, haven't you? Well, sorry, man. It's just literally, yeah, it's just a malformed packet. Yeah. 23, what will it be? Oh, okay. Nearly was a malformed packet, but enough data got through. Cool. Yeah, it's Apple again. Yeah, 44, what will you be? Daikin, what will you be? Or is that Daikin? Like, as in die, as in the vaccine. I very much doubt it. Okay. Yeah, but it's given a public address anyway, so whatever universal is there. Yeah, so it's a public address. So this wouldn't be a randomised MAC address. It's universal, whatever it says there. But yeah, so Daikin, I'm assuming are like a headphone manufacturer or heart rate manufacturer or something like that, or just a Bluetooth MCU manufacturer. But you would see that show up in your scans without access to all those packets there. But you wouldn't see this because obviously that's a random device, as we talked about. OX01, whereas I have to show it again because people are fucking idiots. 0x00 is a public address. Yeah. Yep. Daikin again. Public address. Okay. Yeah. Apple. Sorry, I have to keep peering around my microphone to see what I'm looking at. Same device, isn't it? Let's get a bit further away. That timestamp. Is that the same device? It is. Alright, let's get a bit further away then. Apple. Alright, what I'll do, I'll scroll way down. Get further down. Microsoft. Oh, I'm getting bored of this now. So, like, just randomly picking and then... Oh, Sonasync. There you go. There's a new one. Sonos, that's somebody's soundbar or headphones. Yeah. Yeah, so... Clearly... I lock it. Ah. Is this a Bluetooth lock, maybe? Oh, that's a weird one. I lock it. Oh, battery service, device information. Okay, so it's giving quite a bit away. It's not a capable host or a controller, so that's flag set to false. Its LE general discoverable mode is equals to true and false. Okay, so yeah, so its random MAC address is discoverable, but its public one is not. Well, obviously outside of its pairing mode, which it isn't in at the minute. You get to see some random stuff, but clearly I lock it, whatever that is. Microsoft. Yeah, okay, go down the other way. Google, so that's an Android. Well, a Pixel maybe. Microsoft. Samsung. There you go, that's probably two computers in a shop. You see the MAC addresses are different, but it's the same machine. Unless I just caught it right at the point where it was changing. But yeah, but that Samsung device is advertising there. So you would see that on your batshit crazy anti-vaxxer search. Yeah. Okay. Right, capture TXT. Cool. Oh, there you go. Straight away, there's Daikin. So this is what you would see with the advertising and non-advertising in your phone device. Obviously, forget manufacturer data key, data value. You would not see that, but you basically this is what you're going to see. All these MAC addresses just standing out there with nothing around them, other than every now and again. Daikin. I don't know why that's been. Strange. Turns up everywhere. I think I was just following someone with whatever device that was on them. So at the start of the video you would have noticed the program I wrote dumps the first part of the data into this CSV file as a temporary file, and then that's referenced by our test XLSX. I always found that hard to say. Oh, what the bloody hell's gone wrong there? Oh. Yeah, so this is the temporary CSV file. In comparison to our XLS, which is here, you'll notice we have just say shy of 1800. Sorry, no, 1800. Yeah, but I'll get that set in my bedroom. just shy of 18,000 captures. Whereas what we did with the hash map is effectively we use regular expression just to cut out any recurring data, and just to show you how that works, we cut the data by a third, something like that. So if we look at our data here, yeah, hang on, yeah, so we've got like 10,742 captures here. That's that, whereas on this, so it just shows you how much the hash map has completely taken out of that. Just thought I'd give that there for anyone out there who's wants to program stuff to read and write CSV files and stuff, or any file for that matter, if you want to trim some data out. But you can see how much it's trimmed out of reoccurring data. There's still some reoccurring data in there. That's because there's malformed packets. And as I say, in the next program to write, it's going to be bubble sort algorithms. It's going to be really good. Everything's going to be placed into its own little array objects and setters and getters and references to charts and all kinds of stuff. So I'm hoping to write that. That's with work commitments and stuff. It's probably going to be an ongoing process of a few hours here and there. But yeah, cool. Right, so yeah, let's get on with the rest of the video, shall we? The next part of the video is basically me burying a phone in the ground. Don't ask, it's to basically demonstrate the dielectric constant of soil. But before that, let's see how the anti-vaxxers Bluetooth scanner application of choice stands up against some of our data. graveyard. You horrible cunts.
Bien, pues aquí saludándolos desde un cementerio en alguna parte de la República para que vean que no hay ninguna persona aquí, aparte de nosotros, que no estamos vacunados. Y aquí estamos recogiendo los códigos Bluetooth de personas que ya fallecieron. Por lo pronto en este cementerio, 4 códigos Bluetooth que hemos detectado. Obviamente desconocemos dónde están las personas que fallecieron en 2021 y 2022 y nos estamos guiando por las lecturas de Bluetooth. Estoy alrededor de tumbas de personas que fallecieron antes del 2021 y no se enciende ningún código Bluetooth. Estoy junto a una tumba de una persona que falleció en el
octubre del 2021.
Octubre de 2021. Y justo aquí al lado se encendió un 10º dispositivo. Dice 10 dispositivos. Repito, estamos en un cementerio. Aquí alrededor no hay nadie vivo a la redonda.
The capture. Right then. So, what we've got our hole, got our phone, got a Betty, and we've got a speaker. So speaker, let's connect it to the phone. Stick our phone in a lot of boxes in a bag to protect the screen. And also we've got as well, just tracking the Bluetooth traffic on this. Yeah, she's going. She's going all right. A bit more dense. Yep. No, she's gone. So it's clearly busted. Yeah, and there was a did-it-im, say it's lost it. It's clearly busted. That was about a foot of earth. How the fucking hell is a signal going to attenuate through 6 feet of earth? I mean, 'cause it all adds up to the Bluetooth SIG, all the Bluetooth protocols, the 10 milliwatts through 100 milliwatts. That's what these people are reading. They're getting the same RSI as you would do off a normal Bluetooth device. It's not some magically powerful device. There you go. A foot, no music. That part's busted. Right, let's get on with the rest of the busting, shall we? Right then, so Bluetooth is on. See there, Bluetooth on. Right. Back in the bag. Setting the bag up. Down. bag. Eventually. You can see over the hole we're getting quite a strong return. So we're getting about negative 44 on the RSSI. Right. So just going to fill our hole in. The leaves. Pat that down. Yep. There you go. No. RSSI. Why is that? Could it be because of the dielectric constant of soil attenuating the signal? Answers on a postcard, please. Do it yourself. So we have our Bluetooth scanner app. The same Bluetooth scanner app that well, not all, but a lot of the anti-vaxxers push. As you can see, it's found MAC addresses. We have a TV of Samsung. So we know that TV is Samsung. Now, the anti-vaxxers will have you believe, or lead you to believe, that this application is seeing, because these MAC addresses don't correspond to a manufacturer, they will have you believe this application now. See more coming online, and I'm just in my house. This is neighbours, people passing by, using Bluetooth peripherals, obviously with their Macs randomised as of LE privacy and as of Bluetooth 4.0. Okay, so what we're going to do now is we are going to compare. So this is basically happening, so 64C, let's remember that, 60A4, OBC7, 6243. Let's remember these Macs, and we are going to look at our BLE development application. So 60A4 is Apple. Excuse me. Stupid thumbs. Stupid thumbs. Oh. No. No. There we go. Finally. Big bear thumbs. Okay, so we can clearly see that the company is Apple Incorporated. The 16-bit manufacturer data is there. Let's scroll down. You see, they are clearly that Find My Service is a beacon. So if we look at more, yep. So OX12, it's a beacon. That TV is obviously Samsung. And stupid thumbs again. Oh, that is 7. There we go. Yeah, you'll have to ignore that. I have a hardened case, and the bevel of the screen is like right on the edge of it, and it's quite difficult to get to the burger menu for that there. But yeah, you can see it's Apple. Look at the raw data. And if we look at Flags and Services, you can see it's capable controller and host. So 7782, E827, 64C for top to bow, F4 FB, if we go back to the anti-vaxxers application, or at least it's not an anti-vaxxer application, it's a genuine app. I'm not fingering the developer for developing this solely for this purpose. The developer developed this because you can see the RSSI is on a bar, and that progress bar basically tells you the distance, well, in relation to the RSSI. Yeah, and you can see all those MAC addresses do correspond. Scan again. Do correspond with devices in the wild. Yeah, more devices now. So this is what you can do, or DIY yourself. You can do this. It is no problem at all. So this application is the NRF Connect application. You can freely download that. As we discussed previously in the video, you can also pull the Android HCI Snoop Log off an Android phone and examine that in Wireshark. You can download Wireshark for Windows, Linux, Mac. Just take your phone out, make sure Snoop Log's on, and what you need to do is have this kind of scanner app running, and basically instead of pressing the back button, press the home button and it will run in background. As you can see, that way the Snoop Log takes a reference from the data this application has gathered. If you press the back button, the Snoop Log will basically just look at the HCI module. What you want really is an application running that is constantly looking at MAC addresses and Bluetooth devices, because that way the HCI log will print out what this application is effectively seeing. If you don't have this application running, it won't do that. So have this running in the background, press the home button. Happy days, you can DIY this, no problem. And that's obviously with the Snoop Log as well. So cool. Try it yourself, and in real time you can have the NRF Connect app running. You can see these real-time devices. No biggie, no problem. It is basically anyone can do this, and you can see for yourself. Okay, moving on. Conclusion. So clearly the people, not just the apparent doctor, but these people claiming MAC addresses, they're walking around shopping centres, grave sites, everywhere, with Android phones. And, you know, as we've proven, laptops with Bluetooths that aren't connected to the Bluetooth. So these incompetent bastards are just sniffing and pulling in or scanning random MAC addresses. It's that simple. And I would ask anyone out there to look at my data and prove me wrong. Right. So, clearly this has been a very, very long video. The majority of the video was analysing the packets in Wireshark and obviously the captures. If you have made it this far and I have changed your mind, then I congratulate you on seeing the light and realising the grift. If you have made it this far, and you still deny that under LE privacy, as of Bluetooth 4.0, MAC addresses are randomised when not advertising and or pairing, I'm sorry, you're an idiot. You are an idiot. You've been brainwashed, indoctrinated. You're an idiot. Get help. Other than that, I want to thank you for watching the video. As again, I put a lot of time and effort into these videos, so please like, subscribe and share. Helps the algorithm, helps me get more content out there. I'm not a big channel. I don't want to be a big channel. If I reach a few thousand people and change their minds and their perception on this absolute bullshit, that's all I want. But as again, keep safe. You can do it yourself, and also you can skip through the timestamps. If you've skipped through and you've got to this point and you've not really watched the video, take your time, digest it, watch it over a few times, digest it, have a look at it. It's cool. I don't mind. You can watch the first 5 minutes, the last 5 minutes, the middle 5 minutes, whatever. Cool. This is actually a 2-part video. Yeah, I know, as if it wasn't long enough already, but the second part will be me building the reader program to read my capture program. Also, as well, I'm going to have all kinds of cool stuff going on. It's been probably a week now since I last recorded that part of the video, work commitments, yada yada yada. But yeah, it's going to be so cool, and I'm actually going to publish this to GitHub as a kind of Bluetooth kind of Snoop, Bluetooth sniffer suite as such. Yeah, and clearly there's a lot of work going to go into that. So anyway, thanks for watching the video, and again, I can't stress enough, please like, subscribe and share. This helps the algorithm, it helps me get this content out there, and most importantly, it helps people on the brink of absolute nervous breakdown calamity, thinking the world is against them, to see that the people who are telling them the world is against them are just bullshitting scammers. So thanks for watching the video. Can't thank you enough for being with me this long. If you've skipped the timestamps, so what, who cares? But yeah, cool. Hope you didn't get too drunk if you did get a 6-pack of beers, and I'll catch you in the next one.